Complete this diagram to show how a nuclear fission chain reaction can occur, and we'll add some labels to it. So, first of all, fission occurs when a nucleus of uranium 235 splits into two smaller fragments, and that releases a lot of energy. Now, uranium-235 is the special isotope that is fissionable. However, a lot of uranium is found in the form of uranium-238, which is not fissionable. So we have to enrich the fuel for a nuclear power station so that it contains 2 or 3% of uranium-235 in the fuel rods. Now, some of these nuclei will spontaneously split or fission themselves, but in order to make this process happen, what we can do is fire a neutron into the nucleus, make it collide with the nucleus, and if that neutron is going slow enough, the uranium nucleus will capture the neutron and start to become unstable, and the next step is that it splits, and it'll split into two smaller fragments. So there'll be a fragment over here, a different element, and there'll be a fragment over here, and they play no further role in the fission chain reaction. They also, from this nucleus, will give out 3 neutrons, fast neutrons. So I'm just going to rub out the fission fragments so our diagram is a little bit easier to see what's going on. Just remember that they occur. And we're just going to focus on the neutrons which are emitted from the fissioned nucleus. So these neutrons then go on to bump into other uranium nuclei. And if they're traveling slow enough, and we can make them travel slower by putting them through a moderator such as water. If they're going slow enough, they'll then cause another fission process to happen in this new uranium nucleus and this one as well. And so we have a chain reaction, and those will fission into 2 fragments plus 3 neutrons each, and that'll go on to create even more fissions. Now, in a nuclear reactor, we have to control this process, otherwise it'll run out of control and we'll get meltdown, because each one of these fissions creates an awful lot of energy, and that energy we use to boil water, make steam, and turn turbines to create and generators to create electricity. So in a nuclear reactor, we'll only, on average, let one of these neutrons go on to fission another uranium nucleus. These guys here will probably get absorbed by a control rod. So it's only one neutron goes on to make another fission, and that would be a stable process. So there's a little diagram that illustrates nuclear fission. Make sure that you understand that 3 neutrons are emitted for every fission of a uranium nucleus, and how that can go on to form a chain reaction for nuclear fission.